I've got a problem up here. I want us to evaluate tangent of arc cosine of negative 0.3 all divided by 2. So half of this angle arc cosine, which I'm just going to call alpha. I prefer to call my angles theta, but I'm going to call it alpha just because that was what your book chose to use in giving the half angle formulas. Now, I've written up the half angle formulas, all three versions for the half angle formula for tangent on the board here. I want to just remind you, at the beginning of this section, I said there were no formulas in this section that you had to have memorized. That doesn't mean that I will necessarily give them to you, because I might ask you to derive them. That could very well be what the problem is all about. I could say derive the half angle formula for tangent. Now, if I just said that, you could derive any one of these, okay? I might say derive a specific one, so I might give it to you, but your work would be in showing that that was the half angle formula. Or I might just say derive a half angle formula for tangent that doesn't have any roots in the formula, in which case you could choose whether to derive this one or this one, but again, all of the points would be in showing that work. So I do expect you to practice that, and it's important that you recognize that, because if you're doing the homework isn't going to say derive this formula. The homework's going to say use the formula. What I recommend is every time you're using one of these formulas, you derive it first so that you're practicing that skill. Okay, now on exams and quizzes, I could ask you to derive things. I could just ask you to use the formula. If I do that, I might very well give you the formula. I might say, here's the formula, now use it to evaluate this. But if I don't, then it would just be a bigger question. It would be a two-part question. Derive the formula if you don't have it memorized, and then use the formula to evaluate things. Okay, so I want to evaluate this. I am not going to use this formula. I'm never going to go to this one by choice. I'm going to use either this one or this one. I don't think it really makes much difference. Let's just use this one. Okay, so let's see what we know. Our angle alpha is arc cosine of negative 0.3. So that means that cosine of alpha is negative 0.3. Nice. We know one trig function. And it also means that alpha is in the interval from 0 to pi, because that's the range of arc cosine. Now, of course, that corresponds to quadrants 1 and 2, and here our cosine is negative. So that's going to actually put us in quadrant 2, okay, which is going to mean that pi over 2 is less than alpha is less than pi. Okay. So it's strictly in quadrant 2. I made these strict inequalities because I know alpha isn't pi over 2. If it were, its cosine would be 0. And alpha isn't pi because if it were, its cosine would be negative 1. Okay. Wouldn't be wrong to use inclusive inequalities. This is just more specific. Now, I wrote this because if I were using this version of the formula, I would have to divide this by 2 so I could figure out where alpha over 2 was. I can skip that step because I'm using this formula and there's no plus or minus, so I don't need to know where alpha over 2 is, but I do still need to know where alpha is because I need to know what sine of alpha is. Okay, so we're looking at evaluating sine of alpha, which is going to be our two-step process. Since alpha is in quadrant 2, sine will be positive, and my picture looks something like this. There's my alpha. I'll use beta as my reference angle. Okay. And I'm just going to draw in the right triangle that I get for that reference angle. Okay. So what I know is that cosine of beta is the absolute value of negative 0.3, which would be positive 0.3. And anytime I have a decimal, I'm going to rewrite it as a fraction. 3/10 can be written as 3 over 10. Brilliant. Okay, that allows me to say cosine is the adjacent over the hypotenuse so that I can solve for the opposite side. Okay, so 3 squared is 9 plus p squared is going to be 10 squared is 100. So that means p squared is going to be 91. So p will be the positive square root of 91. Sine of alpha is then I'm going to take sine of the reference angle beta and attach it to this positive sign. So that's going to be root 91 over 3. Fabulous. Okay. Once I know sine and cosine of my angle, I've got enough that I could plug into either one of these formulas. I'm going to use the one that I circled. So tangent of alpha over 2, where alpha is this arc cosine of negative 0.3, is sine of alpha, which we said was positive root 91 over 3, over 1 plus cosine of alpha, which we said was negative 3/10. So that's going to be 1 minus 3/10. I'm going to keep that as a fraction here and simplify. I never want to mix fractions and decimals. That's not fully simplified. So if I have a decimal on the bottom of a fraction, I can simplify that. And the way you do that is by writing that decimal as a fraction. You maybe have a complex fraction, but then we can simplify that. Okay. So right now I do have a complex fraction. I'm going to multiply by 1. I'm going to multiply by 1 in the form of 30 over 30. Because there are two things that I want to cancel. I want to cancel that 3 in the denominator on top and the 10 in the denominator on bottom. Okay, so the smallest thing that will cancel both of those is 30. So if I work this out, the 30 will cancel with the 3 to give me 10, so I'll have 10 root 91 on top. Distributing the 30 on bottom, I'm going to get 30 times 1 is 30, minus 30 cancels with the 10 to give me 3, and I'm multiplying it by that 3, so that's going to be minus 9. So I'm going to get 10 root 91 over 21. And that is fully simplified. Root 91 doesn't have any perfect squares that divide evenly into it, so that's going to be my final answer.